Today we want to talk about linear regression using RStudio. For this example, we're going to generate some data, and then based upon that data, we're going to produce some descriptive statistics to see what we have generated, and then we'll produce the linear regression and understand what's going on there and understand how to interpret this and so on and so forth. So let's begin. So to start with, we need to load the tidyverse library. And then we'll generate the data. So we'll generate gender, we'll generate city, we'll generate payment and happiness. And then we'll wrap everything together using the data frame procedure. And this is how it looks. So we have 600 observations total, but this is the first 10. So we have a female from Prague who's making 9,195 and her happiness is 45. We're having another female from Prague who's making 9,909 and her happiness is 101. We're having a female from New York with 11,604, which is her happiness is 53, and so on and so forth. Now we want to show some descriptive statistics of the results. So we're going to use ggplot for that. So here we can see the distribution of payment. You can see it's rather flat distribution. We can see it have some here. We have a rather lower portion of respondents with that makes less than 5,000. But apart from that, it's a rather uniform distribution. Apart from that edge, this is the density function for happiness. We can see that density function is rather normal. And we can have some more descriptive statistics, but this is the main gist of this is some of the trends that we can see here with the data generated. Now we want to generate the linear model. So the model, this is the model. And now we want to see the results of the model. And we can see the summary of the model. We can see that we have payment, we have gender male, we have city London, New York, and Prague. You can see that we don't have the gender female because the gender female is the variable that we cannot see. So for Lisbon, right, we can see that one of the cities here, Lisbon would be the first city here, so we cannot see it here. We can only see London, New York, and Prague. We can see that here we can see the dependency of the significance of the result. We can see that none of the variables is significant apart from London, which is partially significant, is a borderline significant. We can see that overall the model covers approximately 0.9%. Can explain approximately 0.9% of the variance in the dependent variable, which is a rather low result, but based upon the fact everything is fictitious, it makes sense. We can see the F statistic value, and we can see the degrees of freedom for the F statistics and the p-value for the whole model, the global p-value, which is 32.55%, which is much greater than 5%, which makes it very non-significant. Again, these data is completely fictitious, so it's not necessarily supposed to be too valuable for the statistical matters, but we can see how it can be generated using RStudio. Apart from that, once the model is on, we can generate the fitted values of the model. That means that we can see that the actual values of the model based upon the coefficients. And we can also see the residuals. That means the differences between the variables, between the actual values and the fitted values, the values that came from the model that's produced them. We can do that from the model itself, from the results of the model itself. And this is how it's done. We can see some of it. So here we can see that for that woman from Prague with the happiness of 45, the result, the predicted result was 70, and the difference is 25, negative 25. From the other lady from Prague, and with 101, the happiness was 101, the actual happiness, but the predicted happiness was 69.96, and the difference is 31.03, and so on and so forth. Lastly, we can use a package called stargazer to generate the results of the whole model. So this is how it's done. And once I have it, I can go to my computer and look for result. And this is the result we just produced. You can see it here. Basically, we can see that you can see the very same things that we saw in the more conservative form of the linear regression output. We can see the payment, we can see all the coefficients, the payment, the gender, male, city. We can see the constant, we can see the R-square value, which is very low, 0.01, the adjusted R-square value, and the residual and the F statistic. And overall, we get a legend of the p-values. So effectively, this provides us with a bit nicer way to look at the results produced from R. So this is how we can do linear regression using RStudio.